You are on Ubuntu, right?
What do you say? So please,
What's Linux?
oh, I'm using Ubuntu basically. So at any point in time, please can just ask questions. You understand? Like at any point in time. So
Alright.
yeah, about diamond contract basically, like diamond contracts, it allow you to write upgradable smart contracts on the blockchain, right? Meaning that you can deploy smart contracts whose logic can be changed um, at any given point in time. You understand? Because normally, like when you deploy smart contract, it's meant to be like immutable, right? But with diamonds, basically, you can actually change the logic. You can actually add more like data, more states to the contract that's already like on chain. So people have their own reservations, right, about upgradability. Some will basically tell you that it's not meant to be. Some will be like, okay, it's a good idea because things are softwares are basically meant to evolve over time and all that. But yeah, um, I think when it comes to writing upgradable contracts, there's this Open Zeppelin. I think there are two like popular approach. Right, the first one is Open Zeppelin, UUPS something, upgradable something proxy standard, but the other one is Diamond. And Diamond is the one that I'm more familiar with. Like, so can you still see my screen? Can you still see my screen?
Yeah, yes, I could.
All right, no problem. So yeah, so this is the AIP. I'm on the AIP page, AIP ERC2535, right? So this is the ERC that defines the Diamond Standard, and I'll just quickly walk through it, right? And I'm going to like open like maybe one or two more links, and then just like basically go through some code, right? And I think that will be all for this class. So actually, like Diamond Standard is actually really it's not that difficult to understand, to be honest. But then from this whole description we have here, it says a multi-facet proxy it creates modular smart contract system that can be extended after deployment, which is basically what I just said. But let me just go to the important parts of this document, right? So first one, the motivation. So we have a single address for unlimited contract functionality, right? So despite the fact that you're upgrading a Diamond contract, the address of the contract does not actually change on the blockchain, right? And number two, your contract can exceed the 24 kilobytes maximum smart contract size. So what this guy means is that normally by default, if you are deploying a contract to the blockchain, if your contract has gone, like if you have a lot of functions or a lot of logic in your contract and it goes beyond these 24 kilobytes, right? You will not be able to deploy it, because that's the limit that is actually set on the Ethereum blockchain. So your contract cannot go above this limit. So basically, the whole idea is to prevent things like DDoS and all that. So we don't like spam the blockchain with too much data. So organized contract code, deployable functionality. The Diamond can be immutable. This one is a little bit nuanced, but anyways, the Diamond can reuse deployed contracts. That's like using on-chain libraries that already exist, basically. So to the architecture, when you deploy a Diamond, basically you have what's called a Diamond, right? The Diamond itself can contain logic. It can contain logic. It does in most cases, and then it has data to it, right? So the data are actually the states of the smart contract that are stored on chain. Just like when you create a smart contract, for example, you say in your smart contract you initialize some state, let's say address, owner, or maybe some UINT data or anything basically. right? So the state is actually inside of the diamond, right? And now this facet, basically what they do is they just hold logic that interacts with these states. So a diamond can have as many facets as possible, and that's how we actually overcome this 24 kilobytes maximum contract size. So instead of like putting all the functionalities, all the functions, all the logic inside the diamond, you can split them up into facets, right? And then they are technically, the facets are like independent, they are not part of the diamond. But then using delegate call, you can actually call into the logic of the facets from the diamond. So the facets themselves, they are smart contracts. The diamond itself is a smart contract. The only difference is that for the facets, we don't necessarily need to hold states inside of it, right? The diamond is where all the states of our smart contract system, and if I say system, as in comprising the diamond and the facet, everything. So the diamond itself holds the states or the data, or I don't know if that word they use for it. So all the states that want to store permanently on the blockchain, it will be inside the diamond contract. And then the facet is how we can define logic that will now interact with that data. And this whole diagram here just telling you that facet can be reused across diamonds, right? Like facet A, for example, facet A acts on data A in diamond 1, acts on data A in diamond 2, and facet B acts on data B, and okay, it acts on data B, I guess, in diamond 1 and data B in diamond 2, basically. So this whole part, upgradable centralized private database, like I think these whole parts are like something you can actually go through later. And now when it comes to specification, right? So a diamond basically is a facet smart contract that delegates call into the facet to execute function calls. So like I said, most of the logic of a diamond are inside the facets. The facets are also smart contracts. Like all these terms, basically, I don't know, some, like if you are new to these terms, it can be like a little bit confusing. Diamond, facets, loop, all of them are actually smart contracts, but they just use those terms to distinguish them based on the functionalities that each of them perform, right? So the diamond is stateful. This is the most important thing here. Like the diamond itself is stateful. It is what like houses the states, the data in storage. So the facet is a stateless smart contract, right? I think this is the most important thing for this part. It's stateless, or a library with external function. Basically, like it just has logic to it that can interact with data stored in the diamond. So I think I have one. Oh, I don't know if I can find it. I think I have one. Can't really find it. I think I have one.
Hi, so John. If you have any questions, please don't hesitate.
Yeah, I'm looking for this.
Money not continue, so.
All right. Yeah. There's this this little diagram I drew one time like that. Like I can't even find it again. Ah, shit. Sad juice. Oh, I can't seem to find it. But anyways, I don't actually want to start going with too much detail like loop faces. Basically, loop provides interest. Like I said, all these faces, they are basically smart contracts on their own. They just have like different purpose to each of them. So the loop faces is basically for introspection. Basically, introspection, you just know they're like, all they have is view function, right? View functions to like to observe what goes on inside the diamond. You say is like a magnifying glass that is used to look at diamond. All these terms. Anyways, an immutable function. So basically, immutable function is like normally the diamond is not supposed to have logic, right? Now when you put a function inside the diamond, that function becomes immutable in the sense that you cannot actually upgrade it. Basically, you cannot upgrade it because it is actually part of the diamond itself and not of the facets. And then a mapping is an association, just like a mapping solidity between two things. So yeah, overview, fallback function. So when you call a diamond, when you call into a diamond contract, right, this is where it uses this is how it is able to delegate call to the facets. So it has this mapping basically that maps from the function signature you are trying to call to the facets, right? And if there is a facet that defines that signature, it performs the delegate call here. I think this is the most important line here. Basically, this is where it performs the delegate call to that facet, and this is the facet, right? So all this one, you just like prepare the argument for delegate call and then get the result, and all that. So this is like the structure of how the internal state of a diamond look like, right? So they say they have a function to facet mapping. So it's a mapping, like in Solidity there's something called the function selector, which is bytes, which is represented using byte 4 data type, right? So you take the hash of function signature, I guess, and then you pick the first 4 bytes, if I'm not mistaken. So this first 4 bytes is used inside this mapping to track the facet address that implements it, right? And you can see here that for function 1 and 2, facet A defines them. For function 3, 4, and 5, facet B defines them, right? And this is the facet address. So every contract on the blockchain will definitely have an address, and this facet, they are just smart contracts. Like basically they are just smart contracts that defines logic basically. So they will have an address, and inside the diamond we track those addresses using the mapping, right, from the function that is defined in the facet to their address. So that just it, like, really. And then struct diamond storage, you can actually have other states inside of your diamond, of course. So when it comes to diamond storage, there are two approaches that is recommended, right? The first one is diamond storage, second one is app storage. I think, okay, I'll just go. The main difference here is that when you're using diamond storage, I think I'll just go through the article, but then the main difference is that if you're using diamond storage, basically you store the states, right, as struct in a unique you use a unique but I say a unique position or unique slot. And the way you can have that unique slot is by hashing, let's say using the hash of, let's say, a string that is actually unique to your smart contract, right, or your smart contract system generally. You understand? There are actually other approaches to do that, but the whole point is that these structs are actually stored at unique positions inside your diamond. But for app storage, I think app storage is how you can actually share app storage allows you to share states variable between different facets, right? It makes the whole like sharing of state variable inside different facets to be very much more seamless, right? And so the diamond storage is quite, like, although it lends itself well for having this unique isolated states in your diamond, but then when you want to share it between facets, you have to start calling those functions like here and there. It's not really what's what I'm looking for. It's not really it's not really that it basically is not actually like the best approach to like sharing states between facets, but with app storage you can actually achieve that. I think I'll just go through one or two articles that explains those guys. And what's this? I think this explains how storage works in relation to facets, right? I've gone through this stuff before, but it's been a while. Like, so yeah. For this part, it defines the iDiamond interface, I guess, which is in the interface there's this diamond code that allows you to basically add, remove, or replace functions. Like I said, say for example you have a contract that has a function. Let's say the function is let's say transfer for an ERC20 token. It has this transfer function, allows you to send token from address A to address B, right? So using the diamond code, you can actually replace that function to do something else, or you can actually even remove it. Say you don't want your contract to have that function again, you can basically just like remove it from contract, right? And also you can actually add other functions to your smart contract using this diamond code event. And this is the struct that defines how the facet code should look like. So the first one is the facet address, which is the smart contract address, right? That defines the logic you are trying to, let's say you are trying to add, for example. Now the action can be add, replace, remove. Let's say you are trying to add, and the byte 4 function selector basically. This is just the function selector, right? That is defining the facets that we are trying to add to our diamond. So if you have done Solidity if you actually have like a bit of experience with Solidity, I think you should know about function selector. So it's not really like, it's not really something difficult, to be honest. And let me just see. This one is the introspection, basically, like the diamond loop facet, right? This is the interface of the loop. So the loop facet allows you to look into your diamond and see what is going on, right? So with that, you can actually have an idea that these functions are going to be view functions. Means view function means you don't actually change. They can't change the states on chain, right? What you can just do is basically, like inspect something, and then return it back to the caller, right? So they're not meant to change any states on chain. So like the facet, for example, you can use this one to get all the facet address and their 4-byte function selector, right? Facet function selector. If you pass a facet here, it gives you all the function selector defined for that facet, and facet addresses, basically all facet addresses. And this one, I think this last one, facet address, you give it a function selector, it gives you the facet that defines that function selector. So implementation points, using gas consideration. I think all these ones are like, they are like for today we shouldn't stress on all these ones. Like I always come back and go through all those stuff. So yeah, I want to like show you. Hello, can you still hear me? Can you still hear me? Hello? Hello? Can you guys still hear me? Hello?
Yes, I can.
Okay. So I want to quickly show you the two ways. Let's say so the two recommended approach to working with diamond, right? So I would suggest that you go through this article. I'll just paste it on the chat. Please try and go through this article, it actually explains a lot when it comes to diamond storage, right? Because this is how you are going to store your data in the diamond, right? So basically the idea is that you have a struct, right? You have a struct. Inside your struct, it contains all the data points that is meant to be stored on chain, right? Now, to put that struct in a unique position, you take the hash of a string. This string basically is unique to your smart contracts, right? And then inside you define a function, basically my storage struct, that returns a storage struct, right? And then you set the slot of that storage to that unique position. So if you take a hash of this string, for example, right, what you're going to get is going to be unique for this contract. And if you have another struct again that you want to store, you can take another hash of another unique string, not the same string. Otherwise you have two contracts that are going to like be at the same slot, so they will just basically overwrite each other, basically, right? And if you are going to use, so this is how you define the struct in storage. And if you are going to use that struct in your contracts, right, let's say you have a function, right, in one of your facets that wants to use your storage slot, right? You basically just call your function to get access to that struct, and then you can now basically use it like, yeah, we say my struct dot var1 equal to 10. You set it to 10. To be honest, I understand that it might not be too intuitive at this point, but this is just this for diamond storage, right, pattern. And then there's another one for app storage. So app storage allows you to basically just like share or reuse state variables among facets, right? So so quickly, the way it works is by using Solidity layouts, right? So now you have a struct again with your state variables inside your struct, right? If you import this guy inside the facet, it has to be the first variable defined, so that it will be at slot 0. It doesn't have to be slot 0 though, but any slot you decide to use, you just have to stick to it. That's the point, right? So inside staking facets, we import we import the contract or the file that defines the state variable, and then we initialize it as the first state in our facets, right? With that, we can basically define the function that does interact with that state, and we are good. Very easy. Like this, just like very easy. But then, for the sake of for a library, right? Since we are using this guy as slot 0, what we have to do basically is just define a function that basically sets the slot of the app storage to 0, and that's it. Like that's it, literally. Any other function in your library can just call your app storage, right? And then it has access to that same struct, because this guy is basically initializing the slot of your struct to 0, right? I think I'll just post this one again. Honestly, when you get the hang of this thing, it is actually very simple. And they say the growth staking diamond uses blah blah blah. It's actually very simple, to be honest. Like, it is actually very simple. So let me just paste this one, right? So this is actually very simple. It's just understanding how once you understand how storage slot works in Solidity, right? This is just like a breeze, basically. Understand how storage slots work, understand how library work. This assembly, you can just ignore it, right? But just know that what all this guy does, he just sets the slots of the struct that you pass to this of the struct that you're actually returning from this function. basically, and you can set it to anything. Remember in the other diamond storage, we set it to a unique I don't actually, we set it to a unique, but let's say a unique, I don't want to use a unique number, let's say a unique position, or let's say a unique item, because when we take the hash of this guy, what we get here is actually going to be 32 bytes, right? 32 bytes data that is actually unique. And if we change this guy and we take another hash, it's going to give us another 32 bytes that is actually unique to this string. But the point is that we hash this unique string, right, to get a particular position, and we just set the slots of what we are returning here to that position. Like basically, there's really nothing difficult, to be honest. It's just that when you see this thing for the first time, it doesn't make a lot of sense, right? But then when you get to understand it, like there's really nothing difficult going on here. Basically, there's really nothing difficult going on here. I'm still trying to see if I can hold on 1 second. Let me see if I still have this so this one is basically for the diamond storage, and the other one is for the app storage, right? I don't think I have it.
Mono Paxios.
Oh. Okay, I'm sharing my screen now. So yeah, let me see. I just want to like go through a bit of code, right? That would basically try and at least from the dev side of things, at least show you how, like, what to expect, or I think I've opened too many. It's actually messed up. Let me just close some things. So basically, before I actually proceed, let me say this is this code, like I was about to show you guys, was actually I generated it from this template. So there's this template here, Foundry had at Diamond. Let me just paste the link in the code So basically, this is the template, right? Like if you want to work with Diamond, say you are building a project, right? And you want to use Diamond Standard, you don't have to like start from scratch. You don't have to write all the whole Diamond setup from scratch, right? This template by Timmy Dan actually allows you to just bootstrap your Diamond smart contracts quickly. It has some built-ins that are actually nice, right? And yeah, it has Foundry and other support. So this is what I actually use to bootstrap this this particular ERC20 Diamond implementation, right? So this is like an ERC20 contract using the Diamond Standard, right? And here, I don't know, these guys actually, these are like all in the templates, right? This is diamond.sol, which is the main contract that actually houses the state variable, right? Honestly, I don't like going through codes too much because it can be a little bit intimidating when you're seeing all these lines of code and you don't really understand what's going on. But I'll just try and be brief. So basically, the Diamond itself as a constructor that allows you to like to initialize some states, like the contract owner, and then the address of the facet that will be used to cut the diamond. By cut, we just mean upgrade the diamond, basically, right? And then the fallback function, which you saw from the AIP. This is where we perform the delegate call, right, to any facet for a particular function signature that we want to call, right? Basically, this assembly is a little bit intimidating, but if you use evm.code, you can actually see all the, let me just open this guy. You can actually see all the like most of all the assembly opcode, right? Or what's it called again? These your functions, call data, your specific stuff, assembly specific stuff, call data copy, call data size, switch, default, return data size, and all that. So evm.code basically like it explains most of it. Like for example, call data copy, right? These are like the argument to pass to it. I think data, offset, and then size. So it takes 3 arguments: the data offset, the offset, and then size, right? I won't really go into all the explanation of like what those guys are, but then we actually like just use these guys to like check, to understand more of why they use all this opcode. Even the delegate call, I think delegate call should be somewhere here. Yeah, delegate call. So look at all the arguments past delegate call: the gas, the address, the argument offset, argument size, return data offset, return data size, right? So I can see it. So delegate call, we use gas basically forward all the gas, the facet address, right, for the function we are trying to call, and then this one size, that one size, argument offset size, return offset, return data size, right? So basically that just like within the code, you can actually like go through all this thing and understand most of what is going on here, and it's not a lot, to be very honest. It's not a lot, but then the whole point is that when you deploy a diamond, you have this diamond sitting on chain with the state of your smart contract, right? And then down here is your facet, right? So this facet, basically all they do is they give you functions to interact or to operate on the data in your smart contracts. So I actually drew a very simple illustration, but then I've actually I don't know, I've lost it. I didn't save it, I guess. So yeah, this is your diamond cut facet, right? It's one of the first facets they're going to deploy, and it has this guy that basically defines what this guy does. Is basically defines you know, how to it defines the logic to upgrade the diamond, basically add, replace, remove any number of functions, right? Diamond loop facet, this one basically defines the logic to introspect into your diamond. All these functions are view functions, so you know that we don't actually change the state when we call function in this facet, right? Diamond token facet, I think this is the one that I actually define myself, right? So this facet basically has all the functions for an ERC20 token, basically. And then I think there's also a name facet that I define. This one is just like for the name of the token, basically the name and then the symbol. And ownership, this one, it comes with the ownership facet actually comes with the templates. So what it does, it defines the function to transfer ownership and also to view into the owner of the diamond. So you can only upgrade the diamond through the address that actually deploys or that owns the diamond. Like when you first deploy a diamond, you pass this address to the constructor contract owner, right? So anytime you're trying to upgrade the diamond, if you're trying to upgrade from an address that's not the contract owner, then that upgrade is going to fail, basically. And then permit facets, this one is just for ERC. I think this is, I defined this one for yours ERC I think 712 permits, I guess. Anyways, so yeah, this is the diamond. The most important thing here is this is the diamond, right? This is the diamond, and these are the facets, basically, right? So the interface, the live interface are just like, they're just what they are, interface. They define, you know, interface for your smart contract. They don't really you don't call them, right? You just use them to initialize your facets for the most part. And then the library, basically the library actually also important. The library are they actually define they define actually very important logic that are actually used by the facet. For example, if you look at this facet, let's look at ownership facet, right? The way it's able to transfer owner is by calling these two functions: enforces contract owner and sets contract owner. These functions are defined in this library lib diamond, which is this guy here. So if you come here, you see the functions set contract owner, right, and then enforces contract owner. So the library, basically what they do is that they actually define logic that are now then used by the facets, right, to implement some or most of their functionalities, right? So this library is actually like this is actually like part of the Diamond Standard. So it's actually inside the template, right? So by inside the template, I mean it's part of the Diamond Standard. So there's actually a number of things that is here. Diamond codes is to do the codes to perform the upgrade, and these add functions, you know, replace functions. These ones are actually used internally by Diamond codes, right? And also I think there is initialize diamond codes. I can't really, okay, what does this guy do? I can't really remember what this guy does, but and then there's also enforce has contract code. Basically, if you're trying to upgrade you're trying to add a facet to a diamond, right? This guy basically checks that the contract actually has code, otherwise it's not going to perform the upgrade. So yeah, that is that about the facets. I'm actually sorry if everything is just like scattering in your eyes. It's not too clear, but yeah. So let me see. So basically what we have here, I think some of these tests are actually came with it came with the templates, right? So I don't know if I should run this test. What are we even testing again? Test diamond token. So basically what this test does is, look at this one, setup, right? So this is actually this is using Foundry. So you can write test in Solidity, right? That's the point. So inside your setup, you deploy the facets, the diamond, right? Remember this diamond thing, this diamond contract, right? The constructor takes two addresses. The first one is the address of the contract owner, which we set to this for the sake of testing, and the second one is the address of the diamond cut facet. That means you have to deploy the diamond cut facet before deploying the diamond, and then you deploy the other facets with it, and then you prepare the facet struct, right? And then basically you can actually perform the cut or the upgrade, and then do some initialization if there is to do. And this guy just test. You just basically run the test. I don't know, probably I can just run a simple test. How do I even run? Hold on, let me see. I think it's let me use the Foundry book. I can't even remember the command to run test off my head, but if I'm not mistaken, I think it's Forge. Okay, I think it's Forge test. Yeah. Okay. There's something so just diamond. So basically what I did in this test is I don't know, but if you look at this guy, you see that the first test basically tests some of the functions that are defined in this diamond token facets, right? So we use the address of the diamond, and then we call those functions name, supply, symbol, basically, right? And then the other one that I think is important is the test name facet upgrade, right? So the first time we deploy the diamond, this is what we set the name to, diamond token, and then the symbol, diamond token, DTKN, right? And now when we perform an upgrade, like I said, you can basically like upgrade the diamond. So this is how to do it from our test script, right? We initialize the name facet, and this is the name facet. What the name facet does is define two functions basically that returns a new name and a new symbol for our token, right? So we initialize the name facet, and then we prepare the facet cut struct, right, with the address of the name facet, and then the action here is replace, because we are replacing these functions, name and symbol. These functions were already in the diamond, but now I want to replace it with another facet, right? So we use this replace property of that struct, and then what this guy does basically generate selector is it goes through, it uses FFI. It uses FFI, I guess. Where is it? Yeah. So it uses VM FFI interface to go through. It goes through all the functions in your facet, and then it helps you to just extract the byte 4 selector of those functions. So this came built in with this template, and it's really nice. Basically, it's really nice. So we get the selector because we have to pass that to facet codes, and then we do the facet codes, right? iDiamond facet codes, right? And then we get the name, the new name, the new symbol, and then we now test that okay, the new name when we call it is actually indeed what we are expecting, right? Which is what this guy returns, and then the new symbol token v2. So that being said, if we just if you just call test name facet upgrade, so this is going to run this test, right? And you see that it actually passes, so meaning that we have actually successfully upgraded the diamond to have this name and this symbol. Remember, the first time we deploy it, this is the name and the symbol, right, that we deploy the diamond with. But now after upgrading it changes to this name and this symbol. I'm trying to let me put this to 5. I don't know. I'm trying to get more output from this test. I don't know why it's not okay. Yep. I think 4. So yeah, basically you can see the output, right? Like when we call this, when we do this assert, well, we assert that the name is this and this is that. So but then when we call these guys, the name and then the symbol, right, you can see the call here. You're seeing that even foundry actually shows you that, oh, it's actually a delegate call, because diamond does the delegate call to those facets, right? So you see the call and then you see what the call actually does return, and then you see the other one too. We call name here and then we call symbol here and see what it does return, right? And then don't forget that the first time we actually deployed it, we deployed it with this other name and this other symbol. So if I just say test, for example, test, if I call this guy test diamond token, right? So this is the name and the symbol that we first deployed it with, right? So this is where we deployed it in the setup, right? So after we deployed it, this is the name and the symbol that it actually has, right? But then when we now perform the upgrade, which is a cut to the diamond, basically, right, we can now test that it's indeed the upgrade was successful. So what this upgrade does is basically just replace the functions that are in this name selector, in this name facet, right? We replace those functions, name and symbol. When we deploy the name and symbol, were from here. So this facet now, diamond token facet, right, is what we initially deployed the diamond with. It has a name, it has a symbol. However, the first time we actually run this test, this is what we get: the name and the symbol. But after this facet, right, we have replaced this guy here, this name here, and this symbol here with our own, with a new functionality, right? We just return this v2, and then this is actually a simple upgrade. Basically, most times if you are doing an upgrade, you actually be touching some things that have to do with state. But yeah, I'm not even touching state for this upgrade. We just want to like the goal is just like show you like a glimpse of what upgrading the diamond will actually look like. You understand? And then we can see that when we actually do the upgrade, we get the new function. So anytime we call name, right, it is this name that will be called, not this one, from what we initially deployed the diamond with. So yeah, hopefully that makes some sense. I think this is where I'm going to stop for now. I actually don't have much to say beyond this point. So yeah, John, I actually like suggest that you use some of the materials that I shared, and then hopefully if you have any like any struggle or any question or any challenge, you can always reach out to me on WhatsApp or on the group chat, and then hopefully I should be able to answer. So yeah, for the most part, that's just diamond. It's actually very easy to implement. And once you want to implement in Diamond, like I said, just use these templates. These templates by Timidan actually it does all the dirty work for you. Just come in and define your facets, and you have to go. It does most of the dirty work for you. You don't have to worry about writing some little helpers here and there. It already handles that for you. So yeah, it just nice. So I think that should be that for today. Yeah. Okay, yeah, I'll drop the material. Please tag me on the group. I'll drop all the materials that I use, including this the GitHub to this code base that I actually just showed you. I'll drop everything. So yeah, I think this is where I'm going to be ending the class for now. I don't know if you have any suggestion or you want to add anything.
No. Yeah, it was nice. Thanks a lot.
Alright, no problem.
Thanks a lot, man. So I'm dropping you.